Okay, so yesterday we talked about the two special right triangles, which are 30, 60, 90, and 45, 45, 90, right? These are the only ones in which you can only be given one side, find the other two without a calculator. So for number one, it says find A if B is 10 root 2. So this would be on that triangle on the left-hand side. B is 10 root 2. I want to find A. The relationship between these is what? What are those angles if it's an isosceles right triangle? 45. So this is a 45, 45, 90 triangle. This would be A, and A root 2. So if 10 root 2 is A root 2, what's A? Just 10. Easy stuff, right? Yeah. You could have also done the Pythagorean theorem on that because A is the same. A squared plus A squared would have equaled 10 root 2 squared. It would have given you the same answer. All right, number 2 says find B if A is 19. So this time, here's the 19. This again is AA, and this is A root 2. So B would be what? 19. Good, 19 root 2. 3 says find D and E if C is 4. So now we're dealing with a 30, 60, 90 triangle. If the bottom left is the 60, this is the 30. Opposite 30 would be A. Opposite the 60 would be A root 3. Opposite the 90 is 2A. This is the one I have a value for. So if A is 4, then D is 4 root 3, and E is 2 times 4, or 8. So D, 4 root 3, E, 8. Everybody still good? Questions?
Yeah. Oh, no.
Okay. All right, 4, find C and D if E is 50 root 3. So same relationship. This is A root 3, and this is 2A. So if this is 50 root 3, and I want to solve for A, I'm going to divide both sides by 2, and I get A is 25 root 3. Because both the 50 and the 2 are outside the radical, we can reduce that. So that would be C. C would be 25 root 3. And D would be 25 root 3 times root 3. What happens when you multiply a root by itself?
It becomes
just the number underneath. So this is 25 times 3, which would mean D is 75. Everybody still good? Yeah?
How did you get D?
I multiplied, so because D is A root 3, and A is 25 root 3. Root 3 times root 3 is just 3. So then it's 25 times 3. All right, then I get this one. So it's a little bit of application, right? You're taking two triangles on the outside that are 30, 60, 90 and putting them together in one shape. So on the left-hand side, I've got a 45, 45, 90 triangle. This would be A, and this would be A root 2. So 6 equals A root 2. I would divide both sides by root 2. A equals 6 over root 2, which becomes 6 root 2 over 2 because I have to rationalize it, which becomes 3 root 2. That's this side and this side. So X is 3 root 2. And then on the right side, I've got another triangle. This time it's a 30, 60, 90 triangle. Opposite the 30 would be A, 60, A root 3, 90, 2A. I don't have any measurements on that triangle, but what's that shape in the middle? Okay, for sure it's a parallelogram, and it's got a 90-degree angle, so this is a rectangle. What happens on the left also would reflect on the right. So this is now 3 root 2. So A is 3 root 2, which would make Y 3 root 2 times root 3, or 3 root 6. And Z would be 2 times 3 root 2, which would be 6 root 2. Questions? Everybody's good? Yes? Okay. Okay, we're just going to get a head start on the tangent so that we get a little bit of foundation laid before, and then tomorrow we'll finish the notes for tangent. So chapter 7, section 5 is the tangent ratio. This is the beginning of what's called trig. Trig is like the study of right triangles, right? But these, God bless you, This kind of combines with section 6 to give you like one big section of trig. But we're just going to talk about tangent for today. So the trig ratio is a ratio of the lengths of two sides of a right triangle. And it's used to find the measure of a side or an acute angle in the right triangle. So we're going to learn 3 different trig ratios. We're going to start with tangent today, and we'll eventually learn 3. But each of them are used to either find one of the angles in the right triangle, not the right angle, so one of the acute angles, or one of the side lengths. Unless the angles are special right angles like we just used with 36, 90, 45, 45, 90, these have to be solved with a calculator. So you can set it up without, but then you're going to have to finish it with. Okay, so again, we're going to start with tangent. So this section's tangent. And tangent says that the tangent of an angle is equal to the leg opposite that angle over the leg adjacent to that angle. So these only work with right triangles, which means in my right triangle, I always have a hypotenuse that will neither be opposite nor adjacent. We consider that to be its own special length. Then the other ones are going to change depending on the angle you're talking about. So if I am asking for the tangent of angle A is here, I would say that tangent of A, like this, is equal to the side opposite angle A, so opposite would be side A in this case, and over adjacent, and again remember there's adjacent is next to, right? Technically C is next to it, but so is B, but C is called what? Hypotenuse, so I ignore C and I use B. So I would say that the tangent of angle A is equal to side opposite over the side adjacent, or A over B. Let's say I flipped that and I wanted to know what tangent of B is. What side is opposite B?
AC.
AC or lowercase b, right? And what side's adjacent to B? BC or A. Easy stuff, right? So what will happen is we are going to get 2 of those 3 pieces of information, and then we're going to solve the equation to find the remaining one. So this says express A tangent R as a ratio, and then find tangent S. So R is this angle here, right? Tangent of R is the side opposite R, which is what? 3 over the side adjacent to it? 8. Good. If it had asked you to do it as a decimal, like the warm-up for the next section or a couple of the questions in the homework are going to say, also express it as a decimal rounded to blank decimal place, then that's where your calculator comes into play. You're going to do 3 divided by 8, and I would get 0.375. So you will see times where it says express it as a ratio, and it means this, and then it will say find it as a decimal, and it means this. So what's the tangent of S?
8 over 3.
Good, 8 over 3. And again, if it had said as a decimal rounded, I would divide 8 by 3, and it's 2.666 repeated. If it said to round, it would be let's say it says to round to 4. I think that's what the homework says. It would be 2.6667. Still good? Yes? Everybody's okay? Okay, this is where the calculator comes into play. So, there are 2 different basic types of calculators, okay? One, that when you see the tangent button and you hit it, you see the word tangent. That's one kind of calculator. The other is that when you see the button tangent and you hit it, nothing happens. Okay? So we're going to talk about it as those are 2 different kinds. There's a million different kinds of each of those. Okay? But those are kind of the 2 different kinds. So the 2 on the left, when I hit the button that says tangent, you'll see the word tangent, that one. And this scientific one, I hit tangent, you'll see it. Okay, that's one kind of calculator. The other is like the one on the right, which is like your phone and your iPad. If you hit tangent, nothing happens. So those are the 2 different types that we're going to talk about. The one on the left, when you see the word tangent pop up, you will hit tangent first, then the angle, then equals. The one on the right, you will hit the angle first and then hit tangent. So if I'm doing either the graphing calculator or the scientific calculator, that when you hit the word tangent, it pops up. Then I would do tangent first, and then I would hit 45, and I would hit enter, 45, enter. And both of them give me the tangent of 45 is 1, which should make sense because if it's 45 degrees, it's isosceles opposite over adjacent. They would be the same. If I do tangent 36, I get 0.7265. I'm going to round to 4 decimal places, which means look at the fifth and see if it needs to round up. You're going to hit, yours says tangent when you do it, right? Hit tangent and then hit 1 and hit enter. If you don't get that, check your mode. Your mode has to be in degrees. Sometimes it's in radians and you got to switch it. So that happens like with this button here, degree here. That has to be degree. On a graphing calculator, it's the mode button. This has to be degree. Okay, so if you're getting the wrong answers, that's what that is.
So we round to the...
That, it'll say round to like the 4th decimal place. And then on these kind of calculators and on your phone or your iPad, you're going to do 45 first and then hit tangent. There's the 1. Or you're going to do 36 tangent and there's your 0.7654 and so on. Let me show you one more thing and then I'll let you go. When you look at these examples, you're missing the angle. It's actually telling you the tangent and you're missing the angle. And that's when you use the little button over the button that we used. So I will type in second tangent 2.4751, hit enter, and that's the angle. So if you know the angle, you hit the regular buttons. If you're looking for the angle, you hit the negative ones.
Oh, so you just press second and press...
Second, tangent, and then that, yep. For the last question, you're again looking for the angle. So I'm going to do the tangent -1 of 0.8098. Type that in the calculator. And I get 39.0. So these are the angles. So again, when you're given the angle and you're looking for the actual tangent, you're going to use the regular tangent button. When you're given the tangent and you're looking for the angle, that's when you're going to use that -1.